As we start this chapter on polynomial functions, we begin in this first section with just quadratic functions. We'll eventually work with functions that have a higher degree than 2, but we begin with the quadratic functions. And a lot of what you know about quadratic functions you've already learned in Algebra 2. So we'll kind of quickly review some of those things and throw some extra stuff in too. Okay, so let's start off with the two forms that we have of quadratic functions. We have what we call the standard form, and it is perfect to use if you're trying to graph something, and it easily shows the transformations. Then we have our general form that's usually nicer to use if you're doing anything algebraic, but they do kind of intermix, and we could convert from one to the other, though we're probably not going to spend a lot of time doing that right now. Okay, so the standard form is the one that's nice for graphing, and that's because the transformations are really just sitting there. Remember that A is going to be your vertical stretch or shrink. It also can make your graph flip upside down if it's negative. The H, remember, moves your graph left and right, and you always do the opposite of whatever that sign is right there. And then remember that the K is going to move your graph up or down. All right. If it's not in standard form, it may be in general form. And it's not quite as obvious what those transformations would be when it's in general form, but we actually can still figure out what they are. Okay, so let's start with the vertex. The vertex, and remember that this is going to graph like a parabola. All of these would be nice parabola shapes. So the vertex is really what's telling you you're shifting left and right. So what you're moving, well, you're moving all the points, but specifically we start with the vertex and we move it left and right. Okay, if it's in general form here, we can find our vertex by taking the opposite of b, which is the coefficient on your x term, and dividing it by 2 times your a value, which is your coefficient on your x squared. Okay, so that will get you the x value on your vertex. To get the y value on your vertex, you're just going to plug that into the equation. So you're going to plug in what you found for x, see what the y, or in this case you can see it set up as an f of x, see what you get back. That will end up being your ordered pair. Okay, as far as x and y intercepts, because those are also key parts of a graph, the x-intercept, remember that you plug 0 in for y. Now, in this case, our y is f of x. Now, think about what that would look like if we had a big 0 right here. This would typically be something that we would try to factor. Okay, so then after we do that, we're going to want to factor this. Okay, so for your y-intercept, which is a key part of your graph as well, you're going to plug 0 in for x. Now think about what that's going to do. If I plug 0 in for x, this whole term would disappear, this whole term would disappear, and all I'd have left is c. So I'd have y equals c. So my y-intercept is really always just the constant that you see in the graph or in the equation. Okay, I'm not going to be able to spell that right. Sorry, I ran out of room, but it's the constant or the c value that you have. Okay, so let's practice some graphing. Now these are going to be in standard form to start with. So let's kind of just review that. Remember that this is going to move it right 4 up 2, and so what it's really moving is that vertex right 4 up 2. So here's our new point. Now, to graph this, you have to go back to kind of your parent graph. And your parent graph is y equals x squared. That's the most basic graph where you don't have any shifting at all or any transformations going on. And if you plug 1 in for x, you'd get 1 back for y. If you plug 2 in for x, you'd get a 4 for y. A 3 would get you a 9. And that's the standard shape of a parabola. But as soon as you put in an a value, in this case a 2, okay, that's your vertical stretch. Now my y values equal twice what they would normally be. So what I have to do is have to come over here and take this whole y value. All these y values are times 2. They're going to be twice what they normally would have been. Okay, so if that's the case, then I'm going to start plotting points. From the vertex, I would normally go over 1, up 1. That's what this is saying. But now I'm going to go over 1, up twice that. So I'll put a point, over 1, up 2. And then you can always put your matching point on the other side. Okay, so I would normally go over 2, up 4. Now I'm going to go twice that, so I'm going to go over 2, up 8. Okay, so from the vertex again, over 2, up 1, 2, 3, 4, 5, 6. Okay, it ends up off my graph somewhere up here. I'm going to go ahead and just estimate it and put in its matching point, and that's enough points for me to be able to graph this. And that's our parabola. Okay, let's try one more time. This time I'm going to throw some different types of stuff at us. So if you'll look at number 2 here, when we start off and we look at our shifting, notice that I don't have a k value out at the end. That just means it doesn't move up and down at all. It's only going to end up moving left 1. So let's put a point, left 1, didn't move up at all. Okay, so again, I'm going back to that table I had on my previous one, but this time instead of everything times 2, everything is going to be times negative 1/3. Okay, so the negative 1/3, well, first of all, the negative is going to flip it upside down. The 1/3 is a little bit tricky to take times some of those numbers. If you think about it, now I'm going to go over 1 and down 1/3. That's kind of hard to estimate. I can throw a point on there, but it's not, I'm just guessing. So I kind of like to pick points that work nicely. So I'm going to skip over the 2, 4. I'm going to jump straight to the 3, 9, because 9 is easy to take times negative 1/3. 9 times negative 1/3 would be a negative 3. So that means I'm going to go over 1, 2, 3, down 1, 2, 3, and get a point. Then I'm going to put the matching point on the other side. And I'm going to call that good for getting enough. As soon as I have 5 points, I like to get 5 points on my parabola. And usually I can get it pretty accurate then. Okay, so that's graphing when it's in standard form. Let's try doing some graphing and finding some information when it's in the general form. Okay, so what I would do with that is I'd start off and find my vertex. Remember that the vertex is going to be negative b, which in this case would be a positive 4, over 2a. And my a is actually a 1, so basically it's over 2. Okay, so that reduces nicely to just 2. So the x value of my vertex is 2. And then to find the y value, I'm going to plug 2 into the equation and see what I get back. So I'd have a 2 squared minus 4 times 2, that's an 8, minus 5. Okay, so let's clean that up. The vertex is going to be 2, and then that's a 4 minus 8 minus 5. That's going to get me a negative 9. Okay, so let's go ahead and plot that. Over 2, down 1, 2, 3, 4, 5, 6, 7, 8, 9. So just off of my graph, right here is my vertex. It does open upward because my a value is positive. In fact, since my a value here is the same as when it's in standard form, so since it's a 1, it's just going to be your standard shaped parabola. And so let's see what it says. Find the vertex and the intercepts. Okay, so let's find our intercepts. To find my x-intercept, I'm going to plug 0 in for y. So I'm going to have 0 equals x squared minus 4x minus 5. And this is the one that I'm going to typically want to factor. So this kind of takes us back to chapter P when we were coming up with our factors and solving quadratics. We had kind of reviewed this already. Looks like it's going to be a minus 5 and a plus 1. So then x is going to be negative 1 and x is going to equal 5. Those are my x-intercepts. So at -1 and at 5. Okay, and then the last thing I have are my y-intercepts. And remember, that's when you plug 0 in for x, which works pretty nicely because then you basically have y equals 0 minus 0 minus 5. You remember it's always just the constant. Okay, so my y-intercept is -5. It's going to cross the y-axis right here. And I could even put in a matching point for that over on this side if I wanted to, because I can see this nice parabola shape here. All right, and there's our graph. Now, these points happen to work out beautifully. Typically, when you're working in general form, that doesn't necessarily always work out quite so nice. Let's try another one that maybe isn't quite as perfect. Okay, so I'm going to start off and find my vertex. So that's -b over 2a. Okay, so there's an example. That's not going to be near as pretty to work with. Okay, so now what I have to do is I have to take -1/4 and I have to plug it in for x to see what I get back for y. Okay, so here we go. It's going to be a -1/4 squared. Okay, that's going to be a 1/16 when you square it. But then I have to take it times the 2, so that's going to be 2/16, which simplifies to 1/8. Plus that x value, so it's a -1/4, and then a -3. Now some of you might prefer to go decimal on this. I'll let you do that if you want to go decimal. I kind of like to practice those fractions. It's good number skills. So what I'm going to do is I'm just going to get a common denominator of 8 so that I can combine all this stuff together. So it's going to become a 1/8. I have to take this times 2 over 2, so it's going to be -2/8. And this one I have to take times 8 over 8, so -24/8. And so in the end, I end up with a 1 minus 2 minus 24, so that'd be a -25/8. Isn't that pretty? Okay, now, in the end, if I were going to graph it, I'm going to have to estimate it anyway, so I could write it as a decimal or as a mixed fraction to kind of get an idea. In fact, let's go ahead and do that. So that would be what? 8 goes into 25 would be 3 1/8. So my vertex is left 1/4, down 3 1/8, so somewhere right there. And so that's certainly not going to graph beautifully. Okay, so let's go find our x and y intercepts and see how those work. X-intercept, we're going to plug 0 in for y and then factor. Okay, that'll get me, let's see, a +3 minus, that factors nicely there. Okay, so x is going to equal, in this first one, if I set it equal to 0, I'm going to subtract 3 and then divide by 2. On the second binomial, I'm just going to add 1, so I'd have that. So those are my x-intercepts. Now those aren't actually all that bad. Crossing at 1 and -1.5 is what 3/2 is. Okay, so let's get one more value in there. Let's go ahead and find the y-intercept. And that's when you plug 0 in for x. And so in this case, y is going to end up equaling -3. Okay, so it's just barely there. Okay, so that's enough to graph it. But here's the deal. Typically when it's in general form, graphing is not our ultimate goal. There's typically something more algebraic going on that we would be working with on that. But I'm just kind of showing you a sketch of the graph so you see how that works. Okay, so let's work on writing equations. It says write the equation of the parabola that has a vertex of 5, -3, and it passes through 1, -9. Okay, I could use either form here, but really if they give me that vertex, I kind of know the shifting right off the bat, and I think I could probably write my equation easier in that standard form. So let me write that. Remember, it looks like this. And the h and the k tell me the shifting specifically for the vertex. So if I'm going to go right 5, then I'm going to want this to be x minus 5. And if it's going to go down 3, then I'm going to want that to be a negative 3. The only thing I don't know is the a. But remember that this point that they give me, not only does the graph go through it, but that's an ordered pair that is supposed to work in this equation right here. So let's check it. Let's plug the 1 in for x, let's plug the negative 9 in for y, and let's go figure out what a needs to be in order for this to all equal nice. So I take my y value, which is negative 9, equals, a is what I'm looking for. I plug 1 in for x. And now let's go solve this for a. So this is a times, that's going to end up being negative 4 squared is 16. And then I still have my minus 3 over there. Okay, so I'm solving for a, so start peeling stuff away. First thing you want to do is add that 3. Don't try to do 16 minus 3. Order of operations says that you have to multiply that 16 times a first. I kind of like to write it 16a even, because that's normally how we'd see it. Divide by 16. Okay, and you can see that this does not come out beautiful and would have been hard to see on a graph, so it looks like my a value could reduce to a negative 3/8. Okay, so let's write our equation. Our equation will be y equals, and then you have negative 3/8 is your a value. And then you have your x minus 5 squared, and then your minus 3. And that is the equation of the line that has this particular vertex, but will still go through that point 1, negative 9. Okay, we have one last problem, one that has some application here, and we'll do a little bit of algebra kind of stuff. It says find the number of units of an item sold that produces a maximum revenue given by this function, where R is the total revenue and X is the number of units sold. So we're trying to figure out what the X value is. How many units do we need to sell where this revenue would be a maximum? Okay, now it does say that I want to do this without graphing, but I do want you, and we're going to do that, I just want you to visualize what's happening here. This revenue function, if you look at it, it's a quadratic because it has an x squared. So I know that it would graph as a parabola. But the x squared is actually negative, so it is an upside down parabola. So what's happening here is you've got some sort of upside down parabola, and x represents how many units you sold. So as you sell more units, your revenue, which is kind of like your y in this case, your revenue gets to be more impressive. You're making more money. You're making more money. But at some point, that doesn't work out, and you start to lose money as you make more and more and more of those units. So our goal is to find that spot right there, because we want to maximize that revenue, make that y value the highest. So basically what I'm doing is I'm looking for the vertex of my parabola. Well, I don't have to graph this thing to find the vertex. I can just do my negative b over 2a business, because notice it's in general form. There's no parentheses in here. Okay, so I'm going to rewrite this. You don't have to rewrite it. I'm just going to rewrite it so you kind of see the negative 0.1 x squared is actually your squared term and should come first, plus 900x. And there is no constant, so it'd be a plus 0 out there. Okay, if I wanted to find the vertex of this, it's in general form. I'm just going to do negative b, that's negative 900, over 2a. So 2 times negative 0.1 is negative 0.2. Now that's your x value. You'd have to plug it in to find the y value. However, it does, just so that you see what they're asking, it says find the number of units sold. That's my x. X is the number of units sold. So if I could find the x, that really answers the question. The r on that would actually tell me what is my maximum revenue at that point. I might find that too, just because that's often what we're looking for, is how much money can we make. Okay, so I'm just going to my calculator then. I don't really need to go to my calculator. I can do that in my head. If I take negative divided by a negative, that's a positive. A 900 divided by 2 would be 450, but I'm dividing it by a 0.2, so that's actually going to be 4,500. So I would have to sell 4,500 units of whatever it is I'm making to maximize my revenue. And just for fun, let's plug that in. So that's going to be a negative 0.1 times 4,500 plus 900 times 4,500. And I would get 4049550. All right, now it's kind of important to me that you answer your questions, these types of questions, in a sentence so you really understand what did you just find. So I would come back on this problem and I would say something like, you need to produce 4,500 units to maximize your profit. I'm sorry, let me back that up. It's actually not profit. There's a difference between profit and revenue. Revenue is all the money coming in, regardless of what your expenses are. Profit, you have to subtract out your expenses on that. So to maximize your revenue at 4,049,005. Oops, missed my zero in there. Well, that's messy. Can't leave that. Drive me crazy. $4,049,550. All right. Good luck with your homework.